Hello dears, today I want to show you how we can download climate data, for example, earth skin temperature or temperature, specific humidity, wind speed, and any climate data you want for a specific location you can download easily. That is the data I downloaded as Excel file. Let us download a data for a specific location with an Excel file. Okay, go to Google, search for Power Access Climate Data. Okay, this one, Data Access Viewer NASA Power. I also put the link in a description of a tutorial. We have this window and here access data. Okay, here we have some options. We need climate data. As we know, climate data is a renewable energy, so I select renewable energy. Choose a temporal average. Hourly, daily, monthly, and annual. Climatology, I choose monthly and annual. Location, which location to put latitude and longitude. Here just click this symbol, and from here search for your desired location, which location you need. For example, for my thesis I work on Erbil city, so I select Erbil city from Asia, which is located in Kurdistan. Yes, here, that's Erbil. My thesis on this location, so I choose a location here. Yes, I select it. That's the longitude and latitude. And from date, which date, I want the data from 2003 to 2020. However, the site give you the data from 1981 to 2020. Let me select it to from 2003 to 2020. And the format of output file, you have different formats. I choose CSV to get a Excel format. Here the options: solar fluxes and related, parameter for tilted PV panels, parameter for solar cooking, temperature. I need temperature here, temperature at 2 meter due, earth skin temperature. I need earth skin temperature to find the evaporation, for example, so I choose earth skin temperature. Here I only want this one. From humidity, I selected specific humidity and precipitation sum average. Okay, you also you can select wind speed at 10 meters, surface pressure. For example, I don't need wind speed. Okay, parameter definition to know how the site calculated precipitation, specific humidity. Here you can get the definition from parameter definition. Here just select it, for example, precipitation corrected, the bias corrected average of total precipitation at the surface of the earth in water mass includes water content in snow, even snow included. Okay, let us go back. Here just click submit. Now I get my Excel file. Open it. That is the data I get from 1/1 of 2003 through 31 of 12 of 2020. Let us put each data in its cell. So go here and from data, text column, delimited, next, comma. I have to select comma because the data is separated by comma. Finish. Now I have each data in its cell, but as you see, the data is not in a number format, so I have to change it to a number format. Right click, format cells, convert it to date, this one. Okay, and home. I use only annual and years. Oh, this one wrong. Let me select this one. Format cell. Make it number. Okay. I use only this annual and this year but here there is some problem. For example, this one 1221 is not 12 not format number format, so it's a date. If I want to change it, we have to just write 12.21. I think this is a problem for my PC format. This one number, it's no problem, but here is good now. If I click enter, it changed, but it's no matter. You see how I can fix it. 420 is a date format. I have to change it because there is a point after the number. It means it's a format, a date format. So 4.20. Okay. This one also 1.2, and so on. This one also 5.13. Okay. Now you just select it. And right click, format cells, change it to number. Okay. You see now everything is good. Now everything is good. Yes. This one is wrong. 20.1. This one 20.4. Okay. Also, I have to replace the point with a comma to calculate my Excel as a number. Okay. Here, TS related to air skin temperature. For example, I want to draw a curve between your and air skin temperature. Here you can just select it, TS, and okay, insert, chart. This one also 21.12. Okay, that's the data between annual data between from 2003 to 2020 if temperature for each day 20.77 degrees Celsius per day. Also QV2M belong to what? Belong to specific humidity. Let us plot specific humidity. Select it here and this one, or insert. Okay, this one is the specific humidity. I don't want to put access title because my purpose is to just how to get the data. That is the specific humidity. Regarding the last one, which is precipitation corrected sum, and also this data which is belong to precipitation, insert. Okay, that is the precipitation, annual precipitation for Erbil city in Kurdistan. Hello friends, today I want to show you how we can download a shapefile for a country, and also within a country we can extract or clip a specific location to a different shapefile. Let's do it. From Google, search for DivaGIS, and I also put the link in the description of the video, and select DivaGIS, free spatial data, and select country level data. Here you can select the country you want. For example, I choose Iraq, and here we have different options: population, land cover, railroads, roads, inland water. I choose administrative areas. Okay, download it. I determined a folder for my work, YouTube. That's the file I downloaded. Just right click,
extract here. Now we have a shapefile for Iraq. Okay, open the ArcGIS and bring the shapefile. That is the shapefile I have. Select it all except this one. Add. That is a map for Iraq. Here shows the governorate of Iraq, and this one shows the cities of Iraq. Click right click and open attribute. Here just show the Iraq Mesopotamia, but for this one, right click open attribute table, shows the all governorate for Iraq: Dulaim, Basra, Al-Muthanna, Diwania, and so on. And this one shows the cities, or the cities belongs to a different governorate. Now we downloaded the shapefile for a country, but if I want to clip or select a specific location here and make it as different shapefile. Here, Arbil Governorate, I want to extract this shapefile from Iraq map. Here, from selection by rectangle, select this one. Okay, I want to extract this one. And from geoprocessing, clip, input feature, Iraq administration 1. Okay, clip feature, Iraq administration 1. Here, output feature class, select folder, YouTube folder. Okay, name it Arbil Governorate. Save. Okay. Now I extract it or clip it. Arbil Governorate. Okay. That's Arbil Governorate shapefile. If you want to see your shapefile, just click this Add Data. You see Arbil Governorate shapefile. That's all. Hello friends, today I want to show you how you can create a precipitation map for a study area as you see, and I will be with you step by step to download the precipitation data which stored from 1901 to 2021, the data for 120 years. Let's do it. First, search for CRU data. High resolution gridded data sets. I put the link in the description of the tutorial. Okay, click it. This one, as you see, a gridded time series data set. This version released 17 March 2021 covers the period 1901 2020. It contains the data for precipitation from 1901 to 2020 with the resolution 0.5 degree resolution. Then from local copy, just click local copy. We have this option is select CRUTES, and we have this different data, precipitation, temperature, select precipitation, which period you want, 1901 to 1910, 1911 to 1920. I select 2011-2020. Show in folder. Okay, cut the file you downloaded and bring to the folder you need. I provided this folder precipitation map. Paste, extract here. Okay, then go to the program ArcMap. Then from Arc toolbox, select multi-dimension tools. Make net CDF raster layer. Input the data we downloaded. Go to desktop. From desktop, precipitation map. Select the data. Okay. Just from band dimension, select time. Okay. Yes. Then we have to download a study area shapefile. I show you how you can download it. After downloading, select it bring your study area shapefile. I put it in document ArcGIS. This is my study area. Select it, then right click, zoom to layer. That is my study area shapefile. Okay. The next, select here, right click, data, export data, select data frame, and from here, that is my file I provide. See, there is Innova download document, desktop, precipitation, and here create another folder. I may need new folder. Okay, select this new folder, add, and here you can precipitation layer, 2011, 2020, and format TIFF. Okay, save. Yes. Then we have to apply projected coordinate system. So from here, just right click, data frame properties, go to here from coordinate system, project coordinate system, UTM, WGS 1984, Northern Hemisphere, according to my location. The location for my study area is in the zone 38 north. So I select WGS 1984 UTM zone 38. Okay. There is some difference. Now I can remove this one. Okay. Again, from this one, right click, export data. This time, raster dataset, data frame. You see, it changed the spatial reference to zone 38 north. Here you can rename, project it. Okay, and here is good. 2020, save. Yes. Now I can remove this one. Then composite bands. Yes. I can add all these bands. Here there's a trick, or here is so important. Why? If you want to find the annual precipitation for 2011, you have to select it only band 1 to band 12, because the sum of all these bands is 120 band. You see, if let's see properties, we have 120 band because we have 10 years. Each year has 12 bands. Okay, let's go. If you want to find annual precipitation for year 2011, you have to select it band 1 to 12. If you want to find annual precipitation for year 2012, you have to select it band from 12 from 13 to 24. But I want to find average annual precipitation from the period 2011-2020. So I select all the bands. Select this one and shift it, and here add. Okay, good. Then from data management tool, raster processing, composite bands. Select all, shift it, Add. New folder. Yes, project it. Make it composite. Save. Okay. Then I can remove all these bands. Just select this one, shift it to the end. Right click, remove. Okay. I can remove this one also. From Spatial Analyst tool, select local cell statistics. I can select this one to here, put this one to here, and make it sum. I want sum of precipitation from year 2011 to 2020. Also rename, make it some precipitation, save. Okay. Then from Spatial Analyst, Map Algebra, Raster Calculator, sum, select sum, and divide by 10, because we have that's the summation for 10 years. Just divide by 10, you get annual average. Name annual. Save. Okay. We can remove this one also. Then from conversion tool, raster to point. Raster to point. Select it, this one. Make it raster data. Okay, good. Then from Spatial Analyst tool, interpolation. You can choose IDW or kriging, natural labor. I selected IDW. Input point feature. Okay. Point ID, I convert or change to grid code. Output, I put it to here and make it the name IDW, refer it to interpolation. Save. Cell size, convert to 30, change it to 30. Then from environment, processing extent, I selected same as layer study area. Okay. And raster analysis as below, convert to 30. Masig study area. Okay. 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 Our interpolation is finished. Let's see the result. Okay. That is a map for precipitation or a precipitation layer for our study area. Let us make a layout for it. We don't need this one anymore. Okay, insert title 2020. Okay, insert legend, next. Okay, next, finish. Property, I have to change the name annual precipitation or precipitation millimeter per year. That's all. I hope it can be helpful. Hello everyone. In this tutorial, I want to show you how we can create a contour map from X, Y, Z data or from latitude, longitude, and altitude. As you see, I have this data X, Y, Z, or long, lat, and altitude. So first I have to save it as, but I want to create a folder, specific folder for it. In this key, new folder, create DEM, okay, CSV, and you could choose CSV MSDOS. Save it. Okay, save it. Yes. And go to GIS from file, add data, add XY data. Here, first we have to connect the folder to the ArcGIS. Choose the folder to which you want to connect it. Okay. This PC, new volume E, and my folder create DEM. Okay, that is the file I have. Select it, add. Here for X field, select side of T12 on X axis. Okay. In Y field, select Y axis, and in Z, select altitude M. And also we have to apply a specific coordinate system for our data. From edit. Okay, that's all the coordinate system is. From world, select it WGS 1984. Okay. Yes, that's the data I have. Now we have to convert it to a TIN file. TIN file. So, write TIN, or it's better to write create TIN. Select it. Okay. First select the path, output path, create DEM, not this one. E, create DEM, okay. TIN, save. Coordinate optional, input feature, we have to input this one, and here we have to select it, altitude M to high field, mass point as it is, this one as it is, okay. Just click OK. Now we created the TIN file, and we have to convert TIN file to raster. Here we have also TIN to raster. You can select this one, or you can write TIN to raster. Search for TIN to raster. Select it, TIN. Just click OK. Okay, now we created our DEM file from XYZ. If I uncheck this one, you see that is the DIM,
And also I can change some properties for it. Right click, properties. I want to change the color, apply gamma stretch. Also I want to apply a cold hot color, for example this one. Apply. Okay, you see the high elevation is 654.9 Oscars and the low elevation is 228.52. That's the DM file from XYZ.
This DM file, this is also a DM file but a different one, but in the same way we can create a DM file. I just combined it in my previous tutorial to create a DM file, and in this one I continue to create a contour. Okay, now we created a DM file SVC. Then just from search for contour. Yes, contour, and insert a DEM. Okay, interval let be 20 meter. It depends on you. For me it's a large area and the difference is about 330 meter. Interval depends on you. Okay, now we created a contour lines, but we can make it more smooth by smooth. Search for smooth in search bar. Okay, smooth line. Input contour. That's the location where you want to save your output file. We have a different algorithm. I choose pick. And regarding the smoothing tolerance, you have to change the you have to pick up or select the unit. I select meter. Smoothing tolerance, my area about 3000 or 4000 kilometers squared, so I select 10 meter. Okay, now this one is more smooth. Okay, this one more smoother, like, however it's not a big difference in my work because it's too much. 4000 kilometers square, a large area, that's why you can't see a difference clearly. Regarding the label, right click, property, select it or tick label feature in this layer, and from label field select contour. Size, you can increase it. Color, which color you prefer. I selected black one. And placement properties, let be perpendicular. Place it one label per feature, place it one label per feature part. Label is on the line, not above the line, and this one important, position of the label on the line. Okay, I think it's good. Apply. Yes, that's the contour map we created. However, it's not clear because the background color, we can change it. Properties, symbology. If I choose this color, okay, now it's good. Hello friends, in this tutorial I make a flow direction for a region. As you see, if you want to create the flow direction like this, you can keep watching to the end. First we have to upload a DEM file from here. I put the DEM file in this folder. You can find your DEM file from the location you save it. Okay, add. And if I make a double click on it, from symbology, go to classify it.
Okay, here I change it to a different classes. I choose, for example, 10. Use health effect, health shade effect, show classes brackets using cell values. Okay. Also, I can apply a different color. I use this hot and cold color. Apply. Okay. The blue shows the high elevation and the red one shows the lowest elevation. Then find the flow direction. From Arc Toolbox, Spatial Analysis Tool, Hydrology, go to flow direction. Then you can drag this one to here. Output file, you can change it. From Arc Toolbox, select flow direction and drag the file to input surface raster. Here you can determine the output location or path. I use this folder, new folder in desktop, and name it to flow direction. Save. What's wrong? The length of this name is too much. I change it. Okay, now it's good. This is optional, don't care about it. Okay. Now I have a flow direction file. Then resample. From you can search for resample here, directly search, or you can use a different way. Windows, search resample, and okay, resample data management. Drag flow direction. Okay. Here you can determine the path. Okay. New folder. No. Flow direction. Flow resample. Okay. Save. And here you can determine the size of your cells, output cell size. Because my area is too much, I use 1250. It's a large area, about 3000 kilometers square for me, so I use this large number. Okay, then we have to change it the file to point. Here you can find raster to point. Raster to point. Okay, select it. Input value. Okay, select the path, new folder, point. Okay, now I have the point file, but we have to know what is the meaning of this one. 1, 2, 4, 8, 16, 32, 64, 128. That's the code. From this code we can know the direction in each point. Okay, I have this one. You see that's the direction. 1 in this direction, 2 for this direction, 4 for this direction, 8, 16, 32, 64, 128. Okay.
Go back to the program. Open. From symbology, go to category. This point ID convert to grid code and take this one, all values. Now we have all values. Okay. And from this point, select this symbol. Here you can determine the symbol, arrow. Search for it. Cutting. Okay. Select it. Angle. You see it's 1. 1, what is the direction for 1? This direction. Here we have angle. You see this one 1, so if make it 90, yes, that is the direction for it. And size, you can decrease size to, let us check. Let's change the size 12. Okay. I want to remove this one, also this one. Yes. And for the second one, cutting, search 2, which is 2. Change it 12. $45. Okay. The third one, cutting, search, size 12, 0, yes, downward. Okay. This one, cutting, minus 45, minus 45, yes, okay. Cutting. Here, cutting is a type of the arrow you choose. Cutting playing arrow. And minus 90. Size 12. Okay. I have to select, change the size to 12 also. $32. Cutting. Minus 135. Yes. Cutting. Again. Select it. Size 12.
minus 180. Okay. Cutting. Select it. Size 12. 180 plus 45, 225 minus 225. Yes, this direction. That's the direction of flow in this region. I hope it can help you. Hello everyone. Today I want to show you how we can download a soil map for a country or a region. As you see here, let's do it. Here, just search for file soil map and select this one. I put the link in the description of the video. You can easily get it. Here you can select it, digital soil map of the world. Click it. Then scroll down. Okay, the end. At the bottom you can find this one, digital soil map of the world. Okay, here there is a different links for the data. For digital soil map for world high resolution map PDF format, this one. This is DSMW. This is digital soil map of the world S3 shapefile. I need this one. Digital soil map of the world IRDAS format. Let's download S3 shapefile. Click it. Okay, I download it. Open. Show in folder. I put this DSM file which I downloaded to this soil map. I created a specific soil file here and extract here. You see, that's the data I have. Now open GIS. Okay, from here, data, and connect it. You can here connect the file. Which file I have? I put my file in downloads. This PC, download soil map. Connect it to the GIS. Okay, that is the file. This is the data DSMW shapefile. Select it, add. Now I bring the soil data into the GIS. Just here, right click, properties, and from symbology, select category, and from value field, select it DOMSOI. Okay, and check this one, all values. Okay, here you can, from color ramp, you can select a different color. I choose this one, apply. Okay, you see the color change it. Then from DSMW, right click, open attribute table. Here shows the countries but in randomly, and that's a polygons, FAO soil, DOMSO soil, that's a code. Just from country, right click, sort ascending. Okay, you see now it just shows Afghanistan or the countries in order. So I want to select it for a country. For example, I want to download soil map for Iraq. Okay, here Iraq. Select it here, first one, shift it and go to down. This one, click it. Yes, I select it now for Iraq. You see, just Iraq soils are selected. Here, go out and right click, export data. Export data. Here for the pass output path, select the file you want. My file is, yes, see user, download soil map. That's my file. Okay, here name it Iraq soil map. Save. Yes. Okay. Do you want to add the exported data to the map as a layer? Yes. Now, you see. Now I can remove this layer for all the world. Okay. You can here just right click, zoom to layer. Then right click, properties, from symbology, category, value field, select it DOMSOL and take this one, add all values, color is good. Okay, this layer is, for example, apply. Okay, you see IJCJELCQA, that's the code. You can easily find the meaning for this one. For example, here from Google, just select for soil map world with legend. This one, yes. Save image, yes. Open. Now, you see the legend, it shows the meaning for all codes, as you see. Now you know the meaning of the code. Let us go back to the my soil. Now you can provide a layout view for it. Okay, as you see. And also from insert, title, properties, 10, 8, 1. Okay. Also, we have to apply add a north arrow. Let be this one. Okay. Transfer map, north direction. Insert legend. Okay. Legend next. Next. Track soil map. Next. Finish. Also, you can insert scale bar. Which type? I choose this one. Okay. That's all. I hope it can be helpful. Have a nice time.